Hey folks, welcome to Open Source Options. Today we're going to go over how you can create a DEM or just a surface raster from a point cloud. This is going to focus specifically on a ground filtered point cloud to create a digital elevation model of the ground surface. Some people call this a DTM or digital terrain model. So let's go ahead and get started on this. I have two programs open right now. First, I have my Anaconda prompt where I have Pdal installed. Now, you're going to need Pdal installed, and I'm going to use Anaconda to run Pdal. And I have a video on this that you can check out if you don't have this set up yet. Very easy to install Pdal with Anaconda. So make sure you have that set up, open your Anaconda prompt. The next thing I have open is Visual Studio Code, and I'm going to use this to create some, they're called pipeline files for Pdal. These are just some old files I have open here. I'll open the folder with the data in it in just a minute. And I want to point out as well that on my website, opensourceoptions.com, I have this post, how to create a DEM or raster from a Lidar Point Cloud. And the directions for this are here. The code for this is here. So if you need to copy the code, go ahead and check out this article, which I will post in a link to in the description. All right, let's go ahead and get started here. So first thing I'm going to do is I'm going to open up a folder with my data in it just to keep all this stuff in the same place and make it easy to run. Ideally, you'd probably want to have your code in a different spot than your data, but for now I'm just going to have it here. So I'm in this this folder here, elevation, lidar LAZ, and I have an LAZ file here that's a raw point cloud from the US 3DEM program. And I showed you in a previous video how to download data from the 3DEM program, and these are those same data I downloaded in that video. So I'm going to put all my code and all my outputs in this file just to keep it easy from the command line. All right, and this is the file I'm going to work with, is this .laz file here. So let's go to Visual Studio Code, and I am going to go to File, and I'm going to open a folder. And I'm going to go to C, temp, elevation, lidar LAZ. I'm going to select that folder. And this might take just a sec to open. Fine. Okay, so you can see I have that directory, the EPT directory, and the LAZ file here. I'm going to create a new file. I'm going to click the Add File button here, which I am going to call... what happened there? Let's add a new file, which I'm going to call the groundfilter.json. Okay, now the JSON file, this is how we specify a PDAL pipeline. We're going to just go ahead and work through this right now. So I want to enter in some curly braces, hit enter. I'm going to make an array called pipeline, which I do like this. And then we'll give it some square braces and hit enter. So my array variables are going to go in here. Now the first thing I want to do is I'm going to use a series of PDAL filters, which are like commands in this, and each set of those filters is going to be within pipeline designated by curly braces. And each filter is going to have a type, so I'm going to give it a type, and this one's going to be filters.reprojection. And I'm going to give an output SRS, and I do that with out SRS, and this is going to be EPSG 26911, and that's UTM zone 11. I forgot to put some of those there, and I'm reprojecting to zone 11 because this is a linear coordinate system, so it's in meters, which makes it really easy to work with the point clouds and PDAL. Okay, and so this will just refilter that so it's in a good format. Now we're going to make another filter, and this filter is just going to give a classification to all the points, and I'm just basically resetting the classification. If you've noticed with LiDAR data, and I showed this in a previous video with QGIS, where I displayed a point cloud, these points have classifications that range from unclassified and ground to noise points to vegetation points. And right here, I'm going to use the filters.assign and then specify an assignment, and the classification for all points designated like this is just going to equal 0. So basically resetting the classification on all these points for now, and we're going to filter them for ground. Okay, now I'm going to enter a comma here. The next thing I want to do is filter out points that are probably going to be noise. And these are points that, I mean, just sometimes the sensor returns bad values, or the way the ground is configured, we can have problems. So we're going to use the extended local minimum, which is filters.elm. So we're going to do type filters.elm. And this will take any noise points it finds using the extended local minimum algorithm and mark those as noise, classification of 7. We can then ignore them coming up. And we're going to do the same thing for any outliers. So we'll do type, and we'll do filters, and we'll do outlier. Okay. And now comes the meat of this ground filtering algorithm. We're going to use a segmentation algorithm or a filter. So let's go type. And this, oops. So filters, we're going to use SMRF or the simple morphological filter. And I have more information on this in the website article. But basically, this is going to take the remaining points and determine which ones are ground points and which ones are not ground points. And it's going to do that with the series of parameters that we're going to pass into it. So we're going to ignore some classifications first. So remember how I told you that those previous two filters, the ELM and the outlier, are going to set noise points to 7, and that's according to LiDAR specification rules. Here we're going to ignore anything with the classification of 7. Oops. Okay. And then we want to specify a slope threshold. And the default here, I believe, is 0.15. And so if you don't specify this, that'll be the value. I'm going to put these values in just so you can see what it is, and you might need to adjust these based on your DEM output. And we're going to specify a window size, and this is going to be in linear units for your coordinate system. And it's in meters. I believe the default is 18. And then I'm going to use a threshold value. I believe the default is around 0.5. I could be wrong on this one. I don't remember exactly. And then a scalar, which is an elevation scaling factor. And this will be 1.25. Now, if you're wondering where I got these defaults, I read the paper for this algorithm, the actual primary publication, and they tested which parameters gave the best results over a variety of conditions. And so those are the parameters I'm using. You may need to adjust these parameters for your specific conditions, and I suggest you read the full paper to know what's going on if you want to do that. Okay, so what this algorithm will do, this morphological filter, it will go through all the points in the point cloud, determine which ones are suspected to be ground points, and give them a classification number of 2, and everything else will still have that classification of 0. All right, so we're not actually creating all ground-only point cloud. That's going to happen in this next part of our filter list. And so here we're going to do a type, and we're going to do filters.range. So we can select a range of values here. And so we're going to do limits. And then our classification is 2. And so anything that's classified as 2, which happened in this previous step, we will keep, and we'll get rid of anything else. And now we apply this pipeline to our input LAZ, and and create an output LAZ, and that's going to have only ground classified points in it. All right, so I'm going to go ahead and save this file. Make sure you save your file. And then I'm going to go over and come over to my Anaconda prompt. Now make sure you have Pdel installed in a separate environment. I showed you how to do this in the previous video. So I'm going to do conda activate Pdel py. This will activate my Pdel environment. And then I'm going to cd to my C drive, temp, elevation, and I believe it's Lidar LAZ. So now I'm in the directory that contains both my data and my my pipeline JSON file. All right, and so now what I can do is I can use Pdel translate. I'm going to specify my input file, which is going to be my USGS LAZ file. Specify my output file, which I'll name ground.laz, and specify my JSON, which will be groundfilter.json. Okay, and so I'm going to click enter here, and this will run. And this is going to take several minutes to run. There's a lot of data in this point cloud, a lot of points these algorithms have to go through to figure things out. And so I'm going to pause the video while that happens, and then we will come back and go from there. Actually, so while that's going, let's go ahead and start working on a second pipeline that will then convert this to a raster once it's done. So let's come back over into Visual Studio Code, and I'm going to add a file here, and I'm going to call this, let's call it to raster.json. So let's hit enter, let's get that opened up, and we're going to start with some open curly braces. This is another JSON file, another pipeline file. So we're going to specify a pipeline array. And the first thing we're going to put in this pipeline array before more curly braces is we're going to put a path to our output to the LAZ file we want to convert to a raster. So mine's going to be ground.laz. That's what I named it. I'm going to hit comma, going to hit enter, and open some curly braces for the commands in this pipeline. Now this is only going to have a single command or a single filter. And so let's specify the type. And this is going to be a rider. So we're going to specify, instead of filters, we're going to specify riders. We're going to use PDAL to do this. And we're going to specify a PDAL driver. Oh, I forgot to put a comma in there. So PDAL driver. I'm going to use GTIF, but you can use any PDAL driver that has support within Pdel, which should be almost all of them. The output type is going to be the statistics that are calculated for the raster. I'm going to specify all statistics to calculate. The output resolution, I am going to specify 1.0, and that's going to be in units for your coordinate system of your point cloud. So that's going to be in meters for me, so 1 meter. And that should give us everything, but we need one more thing. I want to put that up here at the top, actually. Not that it matters a whole lot. We need the file name. And I am going to use, we'll just name it DEM example.tiff. And make sure to put a comma at the end there. All right, and then let's save this file. Okay, and so that gives us, we can get rid of this comma at the end and save the file again. Okay, so that gives us the pipeline we're going to run on the ground filtered point cloud to create a DEM. Let's check how we're doing with our ground filter, and it's still running, so I'm just going to go ahead and stop this until our ground filter is finished. All right, so our ground filtering finished. We can just go ahead and check this. You can see that we have this ground.laz output file in there now. So now we can come back to the command prompt and we can run our pipeline to convert this to a raster. So let's do this command Pdel pipeline, and this will just run a pipeline. And we're just going to give it the path to our pipeline file, which I called to raster.json. And now let's go ahead and hit enter, and that will run here. Now this will also take a few minutes to run, but it won't take as long, or I don't think it should take as long as the ground filter command took to run. So once again, I'll pause this and we'll come back in just a minute and take a look at the output raster in QGIS. Okay, so we just finished running that. Let's take a look here. There you go. You can see that we have our DEM example right here. And let's go over to QGIS and we will add this raster in. So we can come over here to our browser and go into temporary files and our Lidar LAZ DEM example. Let's add that thing in there. That's fine. And so there you can see our DEM. Now this is where you might need to adjust your segmentation algorithm parameters a little bit. You'll notice there are a lot of holes in the DEM where it did not interpolate the elevation. And that's okay. We're just going to leave it like this for now, and you can adjust those parameters or adjust your output resolution to fill in some of those gaps. But that shows you the basic process for converting a point cloud to a DEM using Pdel. Once again, the code for all this is up on the Open Source Options website in this article here, which is how to create a DEM from a Lidar Point Cloud. So go check it out there to copy and paste the code. Post any questions in the comments. I will try to get to those, but no guarantee I can get to them. So I get quite a few comments, and I do have to work full time in addition to this. So as always, thanks for watching. I hope this helped you out, and have a great day.